In the last problem, we showed you some of the mathematics with vectors we need to do to start a physics problem. In this part, we're going to show what we need to end. At the end of a physics problem, you'll have a solution to something. For instance, the ball might be going with a velocity of 20 meters per second I hat plus 50 meters per second J hat. But the question asks, what's the final speed of the ball? In other words, they want to know the hypotenuse, not the sides of the triangle. And what you have is the two sides, this and this. And what they want to know is this and that angle. So to do that, we're going to need to finish the problems in physics after we've done all of the great stuff and great calculations. We're going to need to convert our results from Cartesian back into polar representation. To do that, first thing to do is draw a vector sketch. That is to draw the vector like I just did up here. From that sketch, to find a triangle just like I did here. Find the magnitude. The magnitude will simply be the square root of the square of the two sides by the Pythagorean theorem. To find the angle of the triangle like theta here, then you're going to find that the tan of that angle is related in some way to one of these sides. Let's say that that side was B and this side was A. Then it would be B over A. Of course, what it is the opposite over adjacent. And then, the last but not least, this triangle may be here where this angle is measured counterclockwise with respect to the x-axis, as it is in this problem. But you could have vectors that are pointed over here. And when you've solved your triangle, for instance, you found this angle. And the angle that you need to refer to with the x-axis is this angle over here. And so you'll need to draw this picture so that you can see how this angle is related to that angle. Now, if that sounds a little bit confusing, that's okay at the moment. We're going to do some examples. An example worth, they say, 100 words. Well, it really is here. So we're going to do some examples. But the point is that find triangles. Find the angles always being less than 90. And then figure out if that angle is the angle directly with respect to x-axis or not. For instance, in this case, it's 180 all the way around here. If I take 180 and subtract that angle there, I'll get theta. If you start sticking negative numbers and such for the sides into your calculator, you can run into trouble because the tangent that produces a negative tangent, the angle, can either be over in this quadrant or in this quadrant, and the calculator doesn't know which, and so it will choose one for you automatically even if it's not the right one. Always just work with the triangles and find the angles. Draw a picture and let the picture guide you to the correct way to solve it. Remember, in physics, it's not memorization. It is logic that is the key. Memorization is really strong in other fields, but that's not how you do well in physics. You set, you draw, you think. That's what you've been sent to improve your skills in. Okay, starting with the first example, let's do this one. It says A is minus 2i minus 5j in Cartesian form. So the first thing we need to do is to draw us the Cartesian axis. There we go. X, Y. We draw a vector out here. We know that this guy goes along here. Let me change that color. He goes over this way. 2 units. And he's going down 5 units. So this vector is pointing out like this. So that's A, where this is 2 and this is 5. And this angle, let's say that angle right there, we don't know. Okay? So, drawing my associated triangle, just a quick freehand. There's 5, there's 2, there's theta, and there's an unknown angle. Well, C is the square root of 2 squared plus 5 squared is the square root of 29. And that's approximately, punching my little calculator here, going to be more than 5 less than 6, 5.39 approximately. The angle theta is the inverse tangent of the opposite side, which is 2, divided by the adjacent side, which is 5. And if I punch that in the calculator, I get 21.81 degrees, or 21.8 degrees. Now, if you draw a picture like this and you tell me that's 21.8, that's fine. But if you want to just write the results at the end, you have to be a little careful here on the next step. Sometimes in the WebAssign, they will tell you, give me the angle with respect to the negative y-axis. But most of the time, they'll tell you with respect to the x-axis. Or if they don't say it, it's assumed from here, counterclockwise is a positive angle. Well, if I went this way, it'd be a negative angle. That'd be a minus 90. And then I got to go another 21.8. So it'd be a minus 90 minus 21.8. So the angle, if I was trying to write this, call this phi, would be minus 90 degrees minus theta, which would be minus 111.8 degrees, or to 3 sig figs, minus 112 degrees. So my vector A is approximately 5.39 at an angle of minus 112 degrees. And that's in polar form. All right, so that's all there is to converting a vector into polar form. Practice, practice, practice till you can get really good at it. It does you no good to do a lot of really great work and then to mess up the answer you give your boss. Okay? So remember, your bosses gives whatever, you're the brain son outfit, they're going to give you the vector, whatever it comes out in polar form, then you got to do the work. You're going to have to convert it to Cartesian, apply some physics to solve whatever problem, and at the end, you got to take your Cartesian representation and convert it back to polar form in most cases to give your work to the teacher or your boss. All right, that covers this section.